In ancient times, people marveled at the sun, moon, and stars. They noticed light from fire and lightning. The early discovery of light was more about observing its sources, like the sun during the day and fire at night. Moving to ancient Greece, thinkers like Aristotle pondered what light could be. They believed that our eyes emitted visual rays to see things. It was more of a philosophical exploration than a scientific one. Fast forward to the Islamic Golden Age, where Ibn al-Haytham stepped in. He was like the first light detective. He figured out that light comes from sources and enters our eyes, not the other way around. He even wrote a book of optics, explaining his discoveries. The Renaissance brought lenses into the picture. Scientists like Galileo and Kepler played with lenses, understanding how they bend light. Meanwhile, Newton rocked the scene by showing that light could be split into colors using a prism. The 19th century saw a bit of a tug of war between waves and particles. Thomas Young's double-slit experiment supported the idea of light behaving like waves. But then, Einstein comes along in the early 20th century, suggesting that light can act like particles called photons. Einstein's work was revolutionary. He explained the photoelectric effect, showing that light behaves like particles, but still it has this wave-particle dual nature. Imagine light being both a wave and a tiny particle at the same time. Nowadays, we have got a more complete picture. We know that light is this incredible dance of wave and particle, and it's a fundamental part of everything we see and experience. We use light in technologies, medicine, and everyday life. It's like we're still uncovering the secrets of this ancient marvel in modern ways. Think of light as an invisible force emitted by sources like the sun or lamps. Our eyes act as a special detectors, sensing this unseen phenomenon called light. Light is not a single entity, it's a blend of tiny particles known as photons, acting as a messengers to bring us the magic of illumination. Interestingly, light has a dual identity. At times, it behaves like smooth waves akin to ripples in water, and at other times, it acts as these tiny particles, moving at an incredible speed, much faster than anything we encounter. Light instantly brightens a room when a switch is flipped. Colors in light from a rainbow palette due to varying length, from short waves for violet to long waves for red. Ever marveled at a rainbow? It's a nature showcasing the diverse colors light can create. Light also exhibits intriguing behavior when interacting with surfaces like mirrors or glass. It can bounce off like a ball hitting a wall or bend when passing through materials, causing optical illusions like the apparent bending of a straw in water. In essence, light is a fascinating force that, while invisible, brings vibrancy and magic to our perceptible world. So light has this cool thing going on. It's like a superhero with a dual identity. Sometimes it acts like a smooth wave, kind of like ripples in water. Other times it behaves like these tiny particles we call photons. This nature of light is explained by two major ideas of light. Now, scientists have two big ideas to explain this. First, there is the wave theory of light. It's like saying light is a bit like music. It can have interference and diffractions, which is just a fancy way to saying it can wiggle and bend. Then there is the particle theory of light, also known as quantum theory. This one says light is made up of tiny packets of energy called photons. These photons are like little energy particles, and they are the reason light can do some really cool things. Let's clear up some commonly asked questions about light. First one is, how does light travel? Understanding how light travels is like appreciating a beautiful dance of waves. Picture these waves as dance partners, one electric and the other magnetic, moving in a coordinated way, creating the magical phenomena we call light. Unlike other travelers, light does not need a specific road. It can gracefully move through space, air, water, or anything else, almost like a free-spirited wanderer. In the past, it was believed that everything required a medium to travel through, like sound needing air. However, Einstein challenged this notion, revealing that light is different. It does not need anything and can travel through empty space. As light strolls along, entering new realms like air or glass, it undergoes a fascinating transformation. It does not slow down, but it bends or refracts, akin to walking from grass to a sidewalk. This bending of light is the reason why a straw may appear distorted when placed in a glass of water. In essence, the journey of light is a simple yet awe-inspiring exploring of its versatile and dynamic nature. The second question is, what is the speed of light? Light travels at an astounding speed of 29 crore 97 lakh 92,458 meter per second, faster than anything on Earth. Turning on a flashlight, its light can circumnavigate the Earth 7.5 times in 1 second. Scientists denoted this speed as C, a crucial code in understanding universal workings. Einstein's theory of relativity incorporates the speed of light, explaining universal motion. In a vacuum, the speed of light stands as the ultimate speed limit in the universe, showcasing light's remarkable rule-defining nature. Light is not just about brightening our surroundings. Its applications are diverse and impactful. Firstly, in the realm of vision, light enables us to see and perceive the world around us through our eyes. Photography harnesses light to capture moments, as cameras record the varying intensities and colors to create images. Light plays on a powerful role in laser, finding applications in medical procedures, communications, and even everyday tools, like pointers in presentations. The world of telecommunications relies on the light through fiber optics, facilitating high-speed internet and long-distance communications. In the medical field, light plays a crucial role in imaging technologies such as X-rays, CT scans, and MRIs, contributing to diagnostic procedures. Light serves as a versatile tool in various sensors and detectors, from simple light sensors in automatic lights to sophisticated instruments used in scientific research. Optical instruments like lenses and mirrors manipulate light in devices such as telescope and microscope, aiding scientific exploration and medical diagnostics. Electronic displays from TVs to smartphones utilize light-emitting diodes and liquid crystal displays, showcasing the technological applications of light. In the natural world, light is essential for photosynthesis in plants, sustaining life on Earth. Lastly, light therapy provides therapeutic benefit in treating medical conditions like seasonal affective disorder, and the art of holography utilizes light to create three-dimensional images. In essence, the applications of light are not just illuminating, but contribute significantly to advancements across various fields. In this brief exploration, we have skimmed the surface of captivating narrative that light waves through our world. Its history, nature, and applications intertwine to form a tapestry that continue to unfold, revealing more wonders for those eager to glimpse the beauty beyond the scientific veil.